See, this is where you saw that guy on the left. Immediately, you should realize that this has to be done as a combination of different elements. When you see something like that, do not jump and make this model and do it with solid elements. Okay? These vertical lines, these vertical supports, we're going to do it with beam elements. You can see there on the right-hand side, vertical lines. That thin, flat, it's not a sheet. We're going to model it as a sheet with shell elements. You see it over there. And of course, you have something bulky there. Some of you may decide adventurously to go and model this guy, this solid object, as a beam. Make sure you do it right. I'm not teaching you that, and I'm gonna review it to see whether you did it correctly or not. But you see that you have to model the solid elements. Okay. Now you have two possibilities. Make this entire thing in a single part. That's option number one. Okay, and I'll show you how to do that. Or make several parts. For example, that sheet, you can make it as a separate part. That cylinder as a separate part. Those lines, either both of them at the same time in one part, or two parts. The point is that you can make this thing as 4 parts, for example, bring it into an assembly, and start from that point on. It is not necessary, but I don't have a control over how you're going to do that. The way I'm going to start right now, and my expectation is that most people we're going to do this thing as a single part, as opposed to creating 4 parts. In fact, creating 4 parts makes sense because you go and buy these things, right? You go and buy these things and then bring it and put it together. It is 4 parts, but we can solve it as a single part. Okay? Are there any questions? All right. So obviously, anything that we do is recorded this year and posted, homework, etc. But if you go and check, for example, the stuff from last year, I don't know, homework or the midterm, I might have done both of them, okay? But remember, that says summer of 2021, okay? It's not summer of 2022. So we'll see how it goes. I see a lot of traffic to the stuff on summer of 2021 for lectures and for things, which is good. At least maybe I missed something here, etc. But 2021 stuff was different. Lectures are different, problems are different, some of them. So. Okay, I'm going to totally ignore dimensions here, and I'm going to create this part for you, single part, initially, with some made-up dimensions, except that I usually put some dimension there so that I know exactly, I know roughly what these sizes are. So let's hypothetically say, how about the length of this thing being, I don't know, maybe, actually the diameter. How about the diameter of that solid cylinder being 10 inches? Okay, I'll make that diameter 10 inches. It's about 25 centimeters. Yeah, why not? Okay, so let's get to this. Because I told you that I'm going to try it as a single part, I'm going to close that. You can still work there, single part, but you're on your own. If it doesn't, you run into problems. Right here. Say okay. Immediately I save it. File, save management, save as, desktop, new folder, 830, single part. How about that? Because if there's time, I'll come back and do this thing as an assembly. Single part. Okay. Go there, go there, go there. All right. Now, I want to make this solid cylinder, so I am going to go to part design. This is generative shape design. I don't want to be there. So I'm going to switch to part design. On that horizontal plane, I will sketch. I said a circle diameter 10 inches. Okay, so let's do that. Radius 5. Okay. Yep. Exit. Exit. Pad it. By the look of that thing, this was probably maybe 15, 20 inches, something like that. Let's put 20, see what happens. Let me see. Yeah, that's good. Looks good. Okay, I'm going to assume everything is made out of the same material. Otherwise, you have to individually put material on these things. Steel, maybe sheet is aluminum, etc. But we're going to make everything the same material. Now we go there. Oops, well, sorry. Okay, now I want to create that sheet. Okay, so in the single part, I'm going to switch workbenches. I'm going to go to generative structure analysis, generative shape design, too many names. And on here's a situation. I want to draw that sheet in the middle of the sky, okay, or somewhere in the middle, not at the bottom, not at the top, okay? So what I'm going to do is create a plane somewhere up there, maybe 10 inches above the base, and then draw my sheet over there, okay? So first, you draw a plane. These are called reference element. In all software, these things are called point, lines, stuff like that, are called reference elements for obvious reasons. Let me move this thing out so you can see the name. Oh, come on. Well, I guess it doesn't come out. Okay, plane. Offset from this bottom plane, 10 inches high, because the whole thing was 20 inches. 10 inches. Oops, 10 inches. There we are. On this, I will sketch that sheet. Okay? So on this plane, I will sketch. Okay, so first thing is, well, if you look at this drawing, it looks something like that. Okay, so the different ways of doing it, let me use a profile to do this so that I can see everything in front of me, like so, like, let me delete this, try it again. Profile, like so. Don't worry about being very precise because you can always go ahead and fix these things, and you should really. Okay, first of all, this, let me make this, control that, control this, symmetric. There we are. And let me move this thing, let me move this whole thing. Because this was not tangent to that, so let's clean it up. This, control that, tangent. Okay, I wanted to move the whole thing to the left a little bit. So let me see. This is what I did. I selected this and moved it like that, but that's really not what I wanted to do. Okay, this, control that. I'm going to make it concentric. Oh, cancel. Okay, let's put some dimensions here. First of all, clean this up so that this doesn't change. So let's make this thing 16, 20. Okay, so let me put a distance between this and that, dimension between this point and this point. Let me make it, when I made it 0, it collapsed. So let's try it again. Try it again. No, because already something is dimensioned. Question, what is this purple? What is this color purple? Over constrained. Good multiple choice question. You have yellow, you have green, you have purple, you don't have orange, but it makes a good multiple choice question. All right, look, I messed it up big time. So I can clean it. I can clean it up. There's no problem. Or I can just delete that sketch and do another one. It's entirely up to you. You have limited time. Okay? Let me do that. I messed it up. I'm not happy about it, but I'm not going to waste your time and my time. Okay? Do it again. So, profile. Okay. These must be parallel. This one control that one. Control the axis parallel. You can spend all the time you want and do this thing, fix it. That's fine. But there we are. Exit. Now, you might say, why don't you do the hole? Why don't you project the hole or draw the hole, trying to make an opening there? You'll see why in a second. This is the border of my sketch. I want to put a surface on that. And that can be done. What are the type of surfaces that we have created? We have created extrude. You draw something and then some curve, extrude in a certain direction. We have done revolve, draw something, revolved it, shafted it. Okay. There's another one that if you have the closed curve, if you have a closed curve like that, you can put a surface through it. It's called boundary. Look at the ways of making surfaces right there. You see that? You have done extrude and revolve. They were in the same thing. This one is a boundary. As long as you have a closed curve, you can do that. If I had a hole in there, it will not do this. You cannot put a surface through something that has a little piece inside of it. Okay. Now, I want that opening there. So now I'm going to project that top circle into his face and split it. Okay. So on that face, I will sketch. I want to sketch a circle that size, so why don't I project that? There we are. And I want to exit. And now if it's bothering you, I'm going to hide that. And there we are. You see that? Now I can use a split. If I had this thing sitting there in the sketch, I would not even be able to put a surface through that closed curve. But anyway, we can do the split. And always read this thing carefully. Element to cut. Cutting element. And which side you want to pick, inside or outside. This is what I want. And we say, okay. Now the other guy is in hiding, so let's bring it up. Very good. So there is a hole that this thing goes through. Then I want to draw these lines, these supports at the top and the bottom. By the way, I am not using any planes of symmetry the way I'm doing it right now. On the test, you have to use plane of symmetry because that surface is pressurized. The bottom of this cylinder is clamped. The top of the bars are clamped. So there is a middle plane of symmetry. You have to do half of this, just half of that. You can either split it now, or you could have created it as half the model. Entirely up to you. But I'm not using any planes of symmetry right now. Good. So I want to create a point, a line here. I want to create a line here going up. So here's a line. And there are different ways of doing it, point and direction, because I know that corner point and I want a height, given height. So let me select this point. And in the direction Z, by some amount, I don't know, let's make it 10 inches, 5 inches, 10 inches. Yeah, okay, 10 inches. Preview right there. Make it taller, 20 inches. Preview. Okay, there's my line. You can do exactly the same thing on the other side, or you can probably reflect this too, but I don't know. The problem is that you don't have a mirror, for example. In one of these workbenches, you don't have the mirror. Don't waste the time. Just go ahead and do it again. Up there, and this is no point. What am I doing here? Cancel. I want a line. Cancel. Cancel. I want a line. Point and direction. This is my point. Direction is Z. 20 inches. And there we are. Okay. Make everything out of steel. There's only single part here, so let's go ahead and apply material to it. Metal, steel on that part. We say OK and immediately save everything. Good. This is it. As far as making the model is concerned, this is it. So now I'm going to go to generative structure analysis. So we go to start, generative structure analysis. You probably go through the menu, analysis and simulation, and then generative structure analysis, or advanced machine tool, whichever. And notice that the familiar thing pops up. Static analysis is what we're going to do. And the only thing that is going to get meshed is that solid cylindrical object. Because Catia, by default, if it sees a solid, it's going to mesh it. Let me change the rendering here. There we are. If you say show me the mesh, it will show you the mesh, but it's only the cylinder that's going to show you, that cylindrical object, which I'm not going to bother showing you the mesh. Now, to do anything else, beam elements, shell elements, you have to do. Okay, so let's do the shell first. So let's go ahead and do the shell element right there. You select the surface. There we are. You see that? That green thing in the middle, that's a shell element. It doesn't have any depth. For now, let me make it parallel, parabolic. Let me also make the size a little bit smaller, maybe 1. Okay. Oh yeah. Okay. So let's look at our mesh. We'll see both of them, the solid ones and the shell ones. That's an overkill for that shell, but that's okay. The lines, it hasn't done anything to it yet. We have to do that. So deactivate this mesh. Okay. Let's put a thickness on this mesh also. There is the 2D property, thickness. See that? Thickness. You click on it. You select that. Since all the stuff that I use is my own dimensions that I made up, I might as well make the thickness of the shell also. So imagine this whole thing is 20 inches long. So, I mean, let's say 0.1. Default is 0.1 is about 2 millimeters steel, right? Steel sheet. Okay, why not? Some software allow you to see the thickness of the shell as a 3-dimensional object, how thick it is compared to the rest of the structure. Catia won't let you do that, okay? Of course, the new version that I'm going to show you on next week, 3D experience, you can do that, but just leave it the way it is. There's nothing you can do here. Okay, now, so what else is left to do? Mesh the beam, mesh the beam element, okay? Now, let's go back to the stuff that we did with beams. When I wanted to model a beam by itself, and we have done it several times, I had 2 options. One of them was to draw it in a sketch, and then exit the sketch, there will be a line there. The other one was make it a true wireframe, just draw a line in space or something in space. What is the difference between the two when it comes to doing the rest of the problem? If I drew it in sketch, which I didn't here, or if I drew it as a wireframe, a line, I used a line, not in the sketcher, I didn't go to the sketcher. What would the difference be? what would the difference have been if I had done this line in sketch that I could have done it, or this line in space as I did it now? If you don't know that step, the difference is that either you can finish the problem or you can't. If you do it in sketch, you must join it. Totally useless, but you must join it. Not so in wireframe. You don't have to join that line. But if you did it in sketch, you had to go join it. Otherwise, you're done. Done for the problem. Pretty much. Can't do the rest of it. I don't have to do that because I drew it in a wireframe. Okay, so let's see. Let's see. Let's try to mesh that line. Beam element. If I had done this in sketch without joining, I would not even be able to pick it. Let's pick it. Okay, it says element size 1 inch. So when you think about it, about 10 elements through the length of this bar, it's fine, no problem. You cannot select it simultaneously. You have to do it one at a time. So we say, okay, another one over there. But believe me, the mesh has been created. If you look at your tree, you can see that there's two one-dimensional beam elements. They were, as soon as I did this, it created it. Now I have to say, what is the cross-section of this beam? The drawing looks like that, so might as well stick to the drawing. If it's circular, don't worry about it. You don't need the orientation point. Just say it's a circle, here's the radius, etc. But if it's to be a triangle, if it's to be anything but a circle or a tube, basically, you have to specify the orientation point. I will do that. I want to make, on purpose, I want to make a bar element or beam element like that. So go back here, 1D property, there we are, right there, 1D property. There's no way you can miss this. It says, what is the shape? And remember from 2 weeks ago that I used a cylinder. I don't want it. I want a rectangular beam. And then I have to go say, what is the size of this cross section? Let's make it 0.1 by 0.1, 2 millimeter by 2 millimeter, something like that. So in the y direction is, by the way, you can put 2 millimeter if you want. And it's going to convert it to inches because of my units right there. But I'll put it 0.1. Okay. And 0.1 here. And we say OK. And we select so this one. Again, I don't know, maybe you can do it simultaneously. Let's see that. Oh, no, it won't let you do that simultaneously. One at a time. Orientation point. See, I can't even close this. So the orientation point, I'm doing, I can't remember, am I doing this one or that one? I think I did this and I switched it. Yeah. So for orientation point, I'm going to select, I can't remember what I did. So let's go ahead. Let's go back. Rectangular 0.1 by 0.1. Okay. The support, I'm going to do this one. The orientation point cannot be on this line. Cannot be on this line. It has to be off that line. So why don't I go and select this point? Now, I want to select this point. It won't let me do that. What is your guess? Why is it they won't let me select that point? A sketch is blocking the view. So let me hide the sketch. Not this sketch is probably hiding. Hide it. Hide it. Hide it. There we are. Orientation point. There. That sketch probably was blocking it. You might say, why did you pick this guy as the orientation point? How did you know that? Let me remind you what the idea behind orientation point was. From that point, you drop the perpendicular to the line. That's why the point cannot be on the line. You drop a perpendicular. That is the direction Y, and perpendicular to it is Z. So you can see that this thing would work. If I had selected a random point here, for example, on that sketch, drop a perpendicular line, Y and Z, you see that it'll give you a beam, but the cross section is rotated by some amount. But because it's way on the other side, there we are. Okay, let's do it. Where is my rectangle? The rectangle. Why can I not see it? It must be somewhere here, but it's so small that I cannot see it. Right there. I could have made it bigger for you so that you could actually see it. Because this is 10 inches, I made 0.1, can't even see the damn thing. It's there. And I do the same thing with the other guy. Okay. All right, so let's go ahead and do it again. 1D property, 1D property on this one, and the orientation is going to be that guy. Dimensions are the same. These are the same thing that they did for the earlier beam. 0.1 by 0.1. I haven't changed these, so it's going to stay where it is. And we say OK, and we are good. So can I see all the elements? Sure, right there. There we are. Shell element, solid element, beam elements. Excellent. So let's deactivate this. The reason that this other guy is not showing because I hit it. Okay, good. So the bottom of this is clamped. The bottom of this is clamped. That's what the problem says. The bottom face, circular face is clamped. I could have done the edge, but it's not my problem. You're solving your own problem. I said face. The bottom face is clamped. Okay. And I can do it also at these simultaneously, but yeah. Okay, I'll put it there, and I put it there. The bottom is there. These things are also, you can see that the clamps are there. Okay, good. So, yeah, all three of them. Now I'm going to put a pressure here on that face. So apply pressure on that face and the 100 psi. Just think about it, 100 psi. Let's find out how much load I'm putting there. This thing was, if I'm not mistaken, was about 10 inches by maybe, let's think about it, 10 inches by 5 inches, something like that. So that is 50 times 100 psi, that's 5,000 pounds. I'm just letting you know, sometimes you better think about these. It's a little bit less because that area is not quite a rectangle. But if it was a rectangle, it would be 5,000 pounds. So let's say 4,000 pounds, something like that. 3,000 pounds. 3,000 pounds is 1.5 ton. Okay, it's almost the weight of a car. Sedan, small sedan. And remember, this is steel. Okay, I understand that. But it was 1 inch, 0.1 inch thick. So just be aware of these things. I'll give you numbers that may be totally useless because the stresses may be so high that material is not going to be linear elastic. That's okay. Let's save it. Save the analysis. File, save management, analysis, save as. Same folder, 830, single part, analysis 1, okay. And let's run it. Oh my God, your worst enemy popped up. Can you tell me what the issue may be? I mean, you can interrogate it, of course. You can say, show me the deflection. Yeah, I'm going to do the deflection, but I want to see whether somebody can give me an answer. What is the issue here? It didn't run, right? So, any suggestions? Yes. Absolutely, absolutely. Okay. Yeah. So let's look at it. Catia can tell us sometimes. It's not always. It's not always necessarily either right or. Well, you can see that there is no interaction between anything. So first of all, you have to say. You have to read what I'm asking you to do to finish this problem. Suppose the plate is welded, perfectly bonded, welded, okay, to the cylinder. Now you might say, well, can I not just take this plate and loosely put it in there instead of perfectly bonded? And common sense tells you that if you put it there loosely without welding it, after you pressurize it, this is going to go down, eventually hit the cylinder, and it's going to stop. You cannot do that with Catia. Can I do it with other software? Yes. Some other software, yes. Catia is not a finite element software. Buried in it is a very rudimentary, backward, backward finite element module, which is okay for this course. Okay? So if I took this plate and loosely stuck it in there and pressurize it, it'll go a little bit down, then it hits the wall of the cylinder, and it stops. But you cannot do that in Catia. That's why I have to tell you that these are welded together. Okay? And there are different ways of doing it. For example, you can take the edge of the plate, that circular plate, that circular hole, and the surface of the cylinder, fasten it. So you create a connection. Okay, let's do that. Let me deactivate this with this thing in front of you. By the way, look, many people can do it. Some people cannot do it. Okay? Those some people cannot do it, or they're not here, or they don't bother watching whatever we do in the lecture. And they want to chew everything the last minute, maybe 2 days before the test, and you start watching from lecture 1 all the way to lecture, I don't know, whatever it is. It's those people who cannot finish it, those people who automatically lose 35 marks for, not 35 marks, 35% for that problem. Okay? I'm just letting you know. All right, so connection. All right, you can use this surface and that surface. That's a possibility. Or you can use the edge of this, which I cannot select now because of that probably projection thingy, and the face. Up to you. Both are correct. I don't care. So let me do this. Okay. So first component, the edge of this shell. It's easier for me to select the surface of this and then hide it. And then for the second component, select the edge of this. Can I do the surface and the surface instead of the edge? Yes. The numbers are going to be a little bit different, but both are doable. Okay, both are acceptable also. I did edge because of the, maybe in the homework, not the homework, but in the book it says edge. Now this is fastened. If you say contact, it's totally useless, meaningless. Contact is between two surfaces. Okay? And you might say that if I had selected that surface and this surface, would that work? No, it won't work. You can try. It won't work. Fasten. So we go here. We know where fastened is. Right there. Fasten, connection property. There's a little white dot here. You want to pick it from there or in your connections. There we are. I noticed it did put some kind of a fastener sign here, which is fine. All right. Let's do it. Run it. And if we fail again, you'll see why. Hopefully you have a feeling for it. Oh. Really? Oh. No, it didn't fail. But it's garbage. Because these beams are hanging from the ceiling. They're doing nothing. You put the pressure on that face. It pulls the thing down. But there's no connection between them. So it ran, but it's garbage. At least you get your 35%. You don't lose the 35%. It's something ran. Something relevant ran. Okay? But you lose marks on the other things. Obviously, connection's not good enough. So, guess what? We can do exactly the same logic. The bottom of this beam is connected to the corner of that sheet on both sides, and perfectly bonded, perfectly welded, fastened, right? Okay, let's try it. Deactivate this. Deactivate that. Okay, let's go ahead and do it. So we need a connection between the end of this beam. So let me hide that surface for you. First component, the end of this beam, this line. Hide this. Bring that guy into the show mode. There we are. And second component is that corner point. Now, if you cannot pick it, it's because of that white thingy. Hide that white thingy. And you can do that from either from that connection. See that was a connection, right? I can hide this from here. Let me put the let me see if hiding this thing will work. Yeah, right there. There. So it creates a vertex to vertex connection. And we're going to call this thing fastened, right? Good. But let me do the other side also. You have to do it as a separate connection. So we say, okay, let's do another one. Let me hide this. First component, the bottom of this. Second component, let me bring this thing into the show mode and hide my line. And once again, it won't let me select that guy. Just hide that last connection, the one that you're doing now. And now I can select it. It's a nuisance, but that's how it works. So I created these last two connections. These last two connections is precisely between the lines and those corners. Fastened, right? And it makes sense. Perfectly welded together. You took a welding gun, torch, and then welded these two pieces together. Great. So let's do it. It was right here. We did it a minute ago, and then we try to select this, one of them, and you get that message. What does it say? This connection cannot connect 2 points. Fastened does not work for point to point. Because think about it. Point to point. You don't have to fasten it. They basically, if it's the same point, it moves together, right? It moves together rigidly. So there is something called rigid connection. Not here. Remember I told you that there are two toolbars here. The first one is face-to-face, and the other one is distance connection. Distance. Remember, there's two of them. We have used numerous times this. All of them we have used except for one. We never use the one for distance connection. And the very first one is rigid. And you select this connection, no problem. You don't see anything fancy there. And another one, another rigid for that guy. No complaint, no complaint. Okay? Point to point, you cannot do fasten. As simple as that. It has to be rigid. Run it. Always pray. Always pray. Work all the time. Okay, so that's good. It ran. I don't know. Running doesn't mean it's right. I just showed you one where the bar was not connected to the sheet. It ran, but it's just not the problem that I want. So let's look at the deflection first. There we are. Okay. Average ISO. Material shading. Good. And you know what? I want to see my elements too. I like to see my elements. There we are. A couple of things. Your first reaction may be that, what? I pressurize this from the top. Why do I go up? Because remember, when you put a pressure, it can be going like that, or it can be going like that. Okay? For us, the way to fix it, just reverse the sign. There is a system behind it. It's not random. There's a system behind it. We don't worry about it. If it goes in the wrong direction, that 100 psi that I put there, make it 100 psi, and hopefully that will give you something that you like. So let's go to the pressure that I put in there. We're almost done. Where is the load? Right there. Pressure. Okay, and you can actually see that if you paid attention to this thing when you were doing it, you can see that the pressure is acting in that direction, opposite direction. And as I said, this is not random. There is a way to do these things in a systematic way, but for us, it's just flip it and run it. And this time it will go down. The heat will go down. Okay, so let's look at the translation. Okay, good. It did go down. But why is it that it doesn't actually look symmetric? Remember I told you there's a plane of symmetry here? Cut halfway between this side and this side, they should look symmetric. That's because you're looking at it from an angle. Let's look at the front view. It better be symmetric. There we are. It has to be symmetric. If what I said is right, it has to be symmetric. Now, why did these beams actually bend like that? Imagine you bought this thing and brought it from Canadian Tire, put it together, welded this thing to that thing, welded the edge of the kind of, well, the beam to this somehow, and then loaded it. Will that come directly down? Well, if instead of a weld you put a hook there, this becomes actually a cable, not a beam. Right now, because we made it rigid, and that point on the shell is actually rotating, it takes the guy with it because we made a rigid connection. Whatever the shell does, this also does the same thing, bends. If it is to be strictly cable, if it's to be a cable so it doesn't bend, when I did this rigid connection, there was a checkbox here which says, okay, you're saying these two things move together, but do you want all the degrees of freedom from one to be going to the other one? If it's a cable, I don't want any translations, any rotations to be moving with the shell. Remember, I said that if you get a hook and put the hook in that hole, then it just stretches it. Okay, so do the same thing with the other one. So if you have cables instead of beams, this was beam welded together. Fat objects welded together. Of course, it's going to bend. The beam is going to weld. But now we're making it cable, and let's run it and look at the view from the front. Okay, right click, activate. There we are. Front view. The beam is acting as a cable, just stretches. And if you say, well, why is it not actually changing color, the beam? First of all, garbage, 72 inches. Look at the deflection, 72 inches. You put the weight of a car on that little 5-inch by 10-inch sheet, which is 2 millimeter long. So garbage, I understand that. But if you want to see the stretching of the bar or the beam, then don't show all this gigantic deflection that masks that. So just select the beams, for example. Selection, just show me 1D mesh. There we are. Where's the other one? Good. Now you can see color. We could not see color because the deflection of that sheet was 72 inches. There's no way you can see a 0.4-inch deflection of the cable. Okay, so I did not have the time to do this thing with assembly. We'll see how it goes. I may do this thing as an assembly. If not, I might make a video and leave it there, or maybe actually on last year's, I'll get to that. This can be done as a part or as an assembly. I just did the part for you. Any questions, folks? Yes. Yes. Very good. On the sheet, right? Symmetry from the sheet. Remember, one thing we know: if this was cut like that, it doesn't move this way. If this is direction, for example, y, no displacement in y, rotation z, rotation x 0. Because what? Sorry. Yes, yes. You have to have no choice with beams and shells. You have to use user-defined string. Okay. Stop this.